Hello everybody. We're gonna start in a couple of minutes. Just hit some GMs in the chat or something so you know that you can hear me or the music. And then we're gonna start with this workshop in a couple of minutes. Hope you're gonna enjoy it. Okay, I see a couple of questions. Cool, the voice is here. I'm gonna shut down the music, by the way, right now. Give me a sec. Okay. Hello, let's go. Yeah, this video is not pre-recorded, by the way, so we're live, but it's gonna stay on YouTube afterwards if you can follow along right now. But yeah, so hello everyone. My name is Andre, and this is another Chainlink Hackathon workshop. Our topic for today is Intro to Hardhat. Okay, let's quickly change the slide. So this is our main topic for today. This workshop is going to be a pure code along. So if you have your laptops with you and you're willing to try to maybe code along with me, you're more than welcome to do so. We're gonna hide this settings banner right away. Okay, yeah, you'll be able to watch it later on YouTube. Thank you very much. So this is the question for anyone who are not able to attend. At the moment, this is live, but it's gonna stay on YouTube. Later. Okay, so to answer the next set of questions, this is the agenda. So we're gonna create a simple Hardhat project. Then we are gonna write some tests using TypeScript. Then we are gonna try to use the Hardhat Chainlink plugin. And then finally, I'm gonna quickly explain to you how to use Chainlink Hardhat Starter Kit, which is basically a boilerplate repo for any hackathon related projects. Yeah, as I said, my name is Andre Rakic. I'm one of the developer advocates for Chainlink Protocol Chainlink Labs. You can see here listed my Twitter and Lance handles. So if you want to follow me there, feel free to do so. Basically, I tweet a lot about Solidity. Sometimes I announce workshops and workshop details like this one. So if you want to follow along after this workshop, ask anything Chainlink related, you're more than welcome to do so on my Twitter or on Lens. So this is the agenda, and this is pretty much it for this template, for these slides. Let's start diving in right into the code itself. Okay, so I'm gonna now present my terminal window. I'm on Mac. If you're using Linux or Mac, it's gonna be pretty much the same flow for you. If you're on Windows, the recommended approach will be for you to actually use Windows subsystem for Linux too. Okay, so let's first share my integrated terminal. I'm gonna cd to desktop and create a new folder, and I'm gonna name it Hardhat workshop. Okay, so this mkdir is basically for creating a new folder and on Linux and macOS operating systems. If you're on Windows, it's gonna be pretty much the same, but the point is that you need to create a folder and then cd into that folder and open your code editor of choice. I'm using Visual Studio Code, but you're more than welcome to use anything you love. So this code is just a simple command that's gonna open Visual Studio Code inside this folder. You can do that manually if you want as well, but this is basically like like a, I don't know, like a shortcut for that. So I'm gonna now stop sharing this screen, and I'm gonna present my Hardhat thing. Okay, so we have a question before that. So why is Chainlink teaching Hardhat and Foundry? Aren't they mutually exclusive? And if so, which one should we choose for which type of project? Excellent question. So basically, to start using, I don't know, to start with the blockchain development, like two of the best choices at the moment are Hardhat and Foundry. And if you want to, like to use Chainlink in your blockchain development, then you'll need to use either Chainlink or Hardhat or Foundry or Truffle or I don't know, ApeWorks, whatever is your preference. So which one to choose? It really depends on the type of problem you're going to solve. It really depends on how you're going to set up your tests, your testing environment. It really depends on your language preferences, because in Foundry, you're going to write your tests and scripts in Solidity, while in Hardhat, you're going to write them in TypeScript or JavaScript. With ApeWorks, you're going to use Python, etc., etc. From what I saw from one of some latest production-ready projects, they tend to combine Foundry and Hardhat as well, because all of these frameworks and tools are basically have their pros and cons. So by combining them, you're gonna use the best of both worlds. So it's really up to you what you're gonna use. Okay, we see that someone is using Sublime Text really well. What is Foundry? Foundry is similar to Hardhat, so it's basically a development framework for writing, testing, and deploying smart contracts. Okay, let's see. We are looking for Visual Studio Code. Perfect. I'm gonna share this. Click this. Okay, so you should be able to see my Visual Studio Code. I'm gonna do something like this. Zoom it a bit so you can follow along, and I'll open the integrated terminal. So you should be able to see this integrated terminal. Basically, just give me a second. Okay. So what I want to do now is that I want to create a new Hardhat project. So to do something like that, I'm going to hit something. So I'm going to first need to check my node version. So node version, I should be able to have node installed. After that, I'm going to type something like this: npx hardhat init, npx hardhat init. Okay, and hit enter. Then this integrated terminal environment is going to pop up. So basically ask me, what do you want to do? Create a JavaScript project, create a TypeScript project, empty config file, or quit. I'm going to select create a TypeScript project and hit enter. Project root, it's okay to be the same as this one. Git ignore, yes. Install dependencies, yes. And we're gonna now wait for everything to be installed and set up. So coffee break. While we are waiting for this to happen, maybe you'll have some kind of questions. So I'm more than welcome to try to answer them. Also, while we are waiting, because there are no any further questions, I can maybe explain to you explain. Okay, there are a couple of questions. I'm gonna wait for that. Okay, give me a second. Okay, while this is installing, okay, perfect. Okay, this is installed. Let's first answer some questions. It's upon us whether we choose JavaScript or TypeScript. Yes. So if you're more familiar with either of those two languages, choose it. I'm going to use TypeScript because I prefer TypeScript. But again, it's totally up to you guys what you're going to use. Where we can find info on node version compatibility. So either like Node.js official website, or specifically for Hardhat, go to their documentation or GitHub so you can see which versions they are support. Okay. Give me a second. General advice for people with little to no knowledge about Web3 development. Excellent question. So to get started with Web3 development, you will first need to learn some of the EVM compatible languages, so you can actually write smart contracts on blockchains. So my suggestion is to start with Solidity because it's the most popular one. There is a really handy Solidity handbook on Web3 Code Camp blog or website. I'm gonna post the link at my Twitter after this workshop because I don't have it prepared ready. And yeah, as being said in the comment section, also like Hardhat documentation is pretty well. After that, Ether.js for Web3 frontend stuff, and then build on top of that. Probably I'll suggest for you then to go maybe to read Mastering Ethereum book or something like that, but it's totally up to you. Why do mostly people use Hardhat instead of Truffle? Personal preferences. Just personal preferences between these two frameworks. When it comes to Truffle, again, you can write your tests and script in JavaScript or TypeScript there as well. Yep. First, understand blockchain working. Yep, that's good advice. And yeah, this is the absolutely fantastic resource, Patrick Collins blockchain development course. Okay, let's continue with the workshop. So we have 4 folders now. We created a new Hardhat project. So inside the contracts folder is the folder where your smart contract is going to live. So all your Solidity files are going to be present there. Inside your scripts folder is where you're going to store your scripts. So they're going to be written in TypeScript, and most of them are going to serve basically for deployment to a blockchain. Inside your tests folder, you're going to find all of your tests. So you're going to store your TypeScript or JavaScript files with tests over there. And finally, Hardhat config, really important file. This is where your Hardhat configuration is going to live. So inside this config, you're going to specify the Solidity version, the network specification for each network, for like your end-to-end tests or deployment scripts, etc. So this is the config part, and package.json is just the standard stuff as we imagined inside any Node.js project. Okay, so we have this lock smart contract here. This is like a boilerplate smart contract developed by Nomic Foundation, by guys who created Hardhat. There's like deployment script for this contract, and there is a sample test for this contract. So this is like an example for you. If we want to compile these smart contracts, what we need to do is to type npx hardhat compile. By typing npx hardhat compile, it's gonna compile this smart contract, generate 2 more folders, actually 3 more folders, and say that the compilation was successful. So the artifacts folder is basically build info for this smart contract. So you can find, let's see, this is the better, yeah. So you can find the source code, the ABI, the init bytecode, the deployed bytecode, etc. All the build artifacts for the smart contract itself. Then there is a folder called cache. So this is just Hardhat exclusive. This means that if I do Hardhat compile once again, it's not actually gonna compile them once again because there is nothing to compile. There is no changes in my smart contract, etc. So this is for performance reasons. And finally, we have this folder called type chain types, which is basically because I'm created a TypeScript project. This type chain is a tiny library, really handy, which automatically generated TypeScript types out of Solidity types here. So it's gonna be easier for me to write tests. Actually, all of these files, cache, artifacts, and typechain types should be present in your git ignore. So it's not really a wise idea for you to push them or publish them onto the GitHub. Okay, now that we started with the Hardhat, let's create a new contract. So inside contracts folder, create simple storage.sol, which is a simple Solidity file. Okay, so I'm gonna hit this, close this, so we can see better. So first of all, you'll need to specify the license. So SPDX license identifier, and I can put MIT, but you can choose whatever license you want. This is basically a license for your smart contract. If you're not sure what to put, you can put unlicensed as well. But I'm going to use MIT. Okay. So next one, I'm going to select the Solidity compiler version, sorry. So I'm going to say something like this. So any Solidity compiler version that is 0.8.0 or higher can compile my smart contract. Because if I go back to Hardhat config, and I can see that Hardhat is going to use 0.8.18 Solidity version for compiling my smart contract. Okay, so it's not gonna result in error. Contract keyword and simple storage. This is like a name of smart contract. I'm gonna save all of this, and once again type npx Hardhat compile. So I compiled my simple storage contract. I have new typings for type chain, etc., etc. Okay. Now that we have like an empty contract, let's do something fun with it. So first of all, we can do something like this: string message. This is a storage variable which is type of string, and it's present in the smart contract. So if I do something like this, function function get message, public view returns string memory, and return message, I should be able to see the content of this message. Because this message is empty for now, what I will see is basically an empty string. So by default, it's empty string. Okay, so to set the message, what I can do is type constructor. So constructor is gonna be executed during the deployment process only. So this is gonna be called only once. So I see here I can type something like this: hello world. Okay. So now when I call this get message, I should be able to see hello world. Solidity has a really handy technique which will automatically generate getters for us if we put public here. So because we put public over here, it's going to create a new getter function called message. So the name of a storage variable, which is going to be exactly the same as this one. So I can easily remove this function as well, because I put public keyword over here. Okay. Finally, I can type something like this. So function set message, which is gonna set new message. So it's gonna be string memory new message. Again, public, and it's gonna set message to new message. Okay, so it's really nice. I don't know, like thing in Solidity is to always emit events. So I'm gonna create a new event called new message, which is gonna have string message, and I'm gonna emit new message with message. Okay. If I type npx hardhat compile, everything is going to work. Okay. So do we have any questions so far? Okay, couple of questions. What is the contract ABI example? So ABI stands for Application Binary Interface. It's a gigantic, not gigantic, but the JSON file, which has, like a set of your smart contract functions, storage variables, public storage variables, etc., etc. So you can easily communicate with your smart contract on a blockchain using your front end, for example. So it's like a I don't know, handy interface for communication from the outside world to the blockchain, to the smart contract on the blockchain. Exactly. Which contains structure whenever you're using. Yep, this is pretty much the thing. Yeah, when you're using Interact, blah blah. Okay, Andrew. How much? Good question. How much memory is allocated for strings? So, if string is under 32 bytes long, it's gonna be stored inside the single slot in storage. But if not, Solidity is gonna treat it as an array of characters. So it's gonna have one slot for array length and a couple of nested slots for the string itself. Why do we need to emit event? You don't, but it's a good practice. And by emitting events, you are basically, so events are searchable through logs. So it's a good practice to emit in events things that you want to read from blockchain, but it's like expensive to store. For example, with this smart contract, I can only read the latest message. But if I want to search for all of the messages, I can only do if I emitted events previously, because I can search logs using like completely off-chain computation. Yeah, pretty much the same. Like we need to emit events if we want to display. So event is literally like a console log from blockchain. What is the purpose of Hardhat in the building process? So it's for compiling smart contracts, so for smart contract development, for writing tests, and for deploying to the blockchain. So testing and okay. So as part of our agenda, I said I can talk faster, yeah, but this is just to have a reasonable pace for everyone to follow along. Sorry about that. But I'll just speed myself up. Okay. So as part of the agenda, I said that we're gonna write some tests. So this is the next chapter: writing tests with Solidity. Okay, with Hardhat. So this is the tests are gonna be in TypeScript. But before that, set message. So at the moment, set message can be called by anyone. So in Solidity, there is something called, there is a nice pattern that you're gonna check the inputs, and then you're gonna update storage variables, and then emit events at the end. So what I want to do is that I want only owner to call my set message function. So to do that, I'm gonna first address. I'm gonna make this private owner. Then I'm gonna say that owner is whoever deploys this smart contract, so message.sender. And I'm gonna create a modifier. So modifier only owner. It's gonna say something like this. So require that message.sender is equal to owner, and if not, only display this error message. Only owner can call. Okay, so this is going to be error, only owner can call. And to be a valid modifier, I'm going to put this and also only owner here. npx hardhat compile. Boom. Okay, so okay, no questions about modifiers. We all know that. Fantastic. Let's continue. So by typing, I'm going to clean this up. npx hardhat test. You're going to execute test suite, because I already said that there are a couple of pre-written tests inside Hardhat. We are now seeing that 9 tests are passing. So tests are located under test folder. Inside log.ts, there are a set of tests for log.sol smart contract. So go create simple storage.spec.ts, which is a test. And then let's create our first test. We can basically put this on the right so we can follow along to see what they have written, but it's gonna be pretty easy for us. So we need to start with the describe block. And here inside describe block, I'm gonna say something like this: simple storage unit tests, and then async function create a new function. Okay. Yeah, let's make this actually a function. Okay. So here I can create a new test by creating a it statement. So it should something. Okay. And here async function create new function. Okay. Sorry about that. Okay. So inside this it statement, I can write my tests. So what I can do, I can deploy this smart contract. I can deploy to a local Hardhat network. I can call functions of this smart contract. I can assert some things, etc., etc. Because of the performance reasons, there is something called fixtures. So fixtures are used for you to deploy smart contract only once, and then we're gonna use the copy of it inside every single unit test. So unit tests, or these it statements, needs to be independent of each other. So like if you have a unit test that for example checks the, I don't know, like that only owner can call a function, then the other one should not be even aware of the existence of that unit test or the owner, etc., etc. So in order to do that, you must either deploy our smart contract to a local Hardhat network inside every it statement, or use fixtures. Fixtures are more faster and they have caching techniques, etc. So to use fixtures, I should do something like this: create a function called async function, I don't know, deploy simple storage fixture, and deploy smart contract. So to deploy smart contract, you should use something like this. So you should write something like this: const simple storage factory is await ethers. So I hit tab, so ethers was automatically imported from Hardhat for me. I'm gonna do something like this so you can see better. So ethers get contract factory, and I'm gonna use simple storage. Okay, save it. Then const simple storage is, again, await simple storage factory dot deploy. And because if we go back to simple storage, we can see that there are no deployment parameters over there. So I can just now hit deploy, and that's it. Okay. Finally, inside, yeah, and I should return simple storage. Okay. Finally, here I should do something like this. So const simple storage await And let's see the syntax. Yeah, load fixture, deploy simple storage fixture. Okay. And this load fixture is coming from, yeah, this thing. Okay, I'm gonna close this now so we can see better that you should import load fixture from Gnome Foundation, Hardhat Network Helpers, etc. So what I can do now is that I can console log simple storage.address, so I can see that this fixture is actually deployed simple storage contract to a local Hardhat network. So once again, npx Hardhat test, moment of truth. Okay, here it is. We can see that we have simple storage unit tests and some address. Okay, so to speed us up, I can only run set of my tests. So I can do something like this, describe only. If I repeat the process, now only this test is going to be run and all of the next ones, obviously. Okay, do we have any questions right now? Okay. Modifier, fantastic. Thank you. Thank you for answering some of the questions. Okay, let's continue to speed us up. As I said, if I change my constructor to accept messages like this, string memory message, and use syntax like this, I'm gonna npx Hardhat compile it one more time. Now the deploy function is going to be red because we're expecting one argument, but we got 0. So an argument for message was not provided. It's really handy user error. So what I can do is const message equal to, let's say, hello world, or not hello world, but something else. And then deploy message. We should now be able to see this message as our message. How? So const message is equal to simple storage dot message, as I said, because we have a public visibility modifier over here. So message is gonna be automatically generated as a getter function. What I can do is I can console log my message and then hit npx Hardhat test. So we have a promise because this is an async call. So with JavaScript or TypeScript, you need to wait for something to be executed. So I'll need to wait for my local Hardhat node to read the actual message. So once again, now we have something else as a message. So this is this message. Okay, so this is not a valid unit test because we're just console logged something. So this unit test is actually should test deployment stuff. So first deployment stuff is that we set up this message to provided message inside constructor. So I'm gonna go back to fixture, export it from fixture. And now what I want to do is basically to have an assert statement. So first I'm gonna import it. So import assert from chai. Okay. So I'm gonna do something like this: assert that message is equal to message here. Okay. If not, messages are not the same, and run npx Hardhat test. Okay, everything's fine. And also, I'm gonna test that the owner is actually message.sender. So how to do that? So if back doc.ts, there is a ethers get signers. Okay, so I'm gonna close this, etc. So with get signers, I'm gonna get some externally owned accounts in Hardhat network that I can use for testing. So I'm gonna so by default, when I call functions, by default is gonna be called by the first wallet or external account, whatever, which is this owner. But I can actually manually specify which wallet is calling, which account is calling this function by doing .connect owner. And now I literally said call this function using owner. So I'm gonna export owner and other account as well. And here I need owner. So what I want to do now is that I want to check who is the owner, but I cannot because this variable is private. But let's see how to do this. Okay, let's make it public. This is the easiest solution. So once again, npx hardhat compile. I can literally get this value from the storage, but this is faster. So here, if I do something like this, so const owner is await simple storage dot owner. If I console log these two values, current owner and owner, I should be able to see two exact addresses. If I hit npx hardhat tests, sorry about that. Current owner is a string, but owner dot address. Sorry about that. Let's do one more time. npx hardhat test. Okay, two addresses exactly the same. So let's see about the type string. Okay, cool. So what I should actually do here is that I should remove this to assert. This should be equal or owner was not set properly. Hit npx hardhat test. And yeah, that's it. Okay, do we have any questions right now? Okay. In get contract factory, you define contract name, right? What's the package we need to import? Yeah, I'm gonna go over here. So it's nomic foundation / hardhat network helpers. This one. I'm gonna actually put it inside the chat. Okay. How to get just remove connect owner part, and that's pretty much it. Not that I'm aware of, but maybe in Twitter. I don't know. Okay, let's continue with the workshop. So go back here. Let's now test the set message function, shall we? Okay, so here I'm gonna do something like this. I'm gonna put this into the right so we can see better what we need to test. So we need to test 4 things. We need 4 things, actually 3 things, sorry. We need to test that only owner can call this function. We need to test that the new message is now set, and we need to test that the correct event was emitted. So to do that, I'm going to create a describe block first. So describe, I'm going to type something like this, set message, which is the name of the function. You can type whatever you want, basically, and then do async function and open new brackets. And now 3 each statements. So let's say first we said it should be called only by an owner async function. Okay. Then let's put this aside, shall we? It should set new message. Okay, and finally, it should emit an event. A proper new message event, to be more precise. So 3 stuff that we need to do. Okay, so first of all, how to be called by owner. So once again, we're gonna load some stuff from pictures. So we need simple storage. We need other account, and that's pretty much it. So here, there is another thing from Chai called, okay, we can move this up, expect. So we are expecting something to happen. And here we're expecting that await simple storage dot actually connect by other account. So now other account is calling this function. Set message to hello world, for example, to be reverted. Okay. Let's now type npx hardhat test, and we have an error. Okay. So it says something like, okay, it reverted with string, blah, blah. So we have a syntax error. So it's going to be right like this. Sorry about that. One more time. So there needs to be a wait statement here. So await, expect, blah, blah, to be reverted. Okay. So again, this is cool. We know that this call is going to revert. Why? Because we have other account, etc., etc. But if I change this to be called by an owner, this test should now fail. Okay, owner, because it's not going to be reverted. Okay, so assertion error. We expected transaction to be reverted, but in reality, it was not, because it was called by an owner. Okay, so this is a new stuff. Okay, clear. Once again, if I called npx hardhat test, everything should be green. But we now know that this function call reverted, but we are not completely confident why. So here we have something called reverted with. So reverted with, expect, and reason. And a reason is this error message from our smart contract. So it reverted because of this error. So if I copy paste here, this here, and once again, npx hardhat test, our test was written even better because we expected that this call we're gonna revert. Okay, let's split it up for better readability. To be reverted with blah blah. Okay, cool. Second thing, we should set a new message. Okay, so once again, I'm gonna copy this thing here, remove other account because we're gonna use it inside this test, and do something like this. So const new message is, for example, Chainlink Spring Hackathon. Okay. So here I'm gonna call the function. So await simple storage dot connect owner, okay, called by owner dot set message to new message, and do something like this. So we call the function. Now what we're gonna do is type const actual message. We're gonna read it from the blockchain. So simple storage message, and then finally we want to assert these values. So again, I can console log it, console log actual message, so you can see it, but this is not a valid test. So here Chainlink Spring Hackathon, blah, blah, but I actually, as you already know, need to assert that actual message is equal to new message. If not, message not set. Okay, this is the error message. Okay, once again, npx hardhat test, everything is working properly. Finally, how to emit events. So once again, I need fixtures. I need new message, const new message, which can be, okay, this is fun, hopefully. And then I'm gonna use expect one more time. So expect, expect that a call to simple storage from owner set message to new message is gonna to emit a new event. So emit have two parameters. First one is contract. So contract is simple storage. And second one is event name, which is new message, right? So this is the event name, new message. But what we can see here that this event has some arguments. So what I can do now is to type with arguments, and the argument is new message. Okay. Once again, npx hardhat test. So we can see that everything's working fine, and it is. So once again, for better visibility, to emit. Okay, here it is. Once again, npx hardhat test. Do we have any questions so far? Missed out a bit. Can someone copy paste the test file written so far? Please. Yeah, I can copy paste it. Hopefully, it's gonna be here. Let's see. If not, sorry about that. I kind of broke YouTube, but yeah. For what do I need test? I could deploy a smart contract and on a testnet, and well, yeah, but tests are important because you can, besides unit tests, there's a lot of other testing techniques like fuzzing, etc. It's gonna basically prevent your minimize the possibility of bugs in your smart contract. Let's say like this. Exactly, troubleshooting, etc. And yeah, this is the most common reason. Test book trust. What is the difference between task and script? I'm gonna display I'm gonna show it right now. Yeah, this is correct. You're using load fixture as a first. Yeah, this is correct. So what I can do is basically I can have here, because this is describes type, I can have before each and then async function like this, and then sorry about that, I can say const simple storage contract, and then sorry, it's gonna be let, and then here I'm gonna do something like this, and then I'm gonna say simple storage contract is simple storage. And now what I can do here is that I don't need to use fixture, I can use contract. And yeah, but it needs to have a type called simple storage. Yeah, let's see. From type chain, give me a second. Here, and oh, sorry about that. Should be here. And now, yeah, I should have other user, and then user is, let's see, user is other account is type signer with address. This should come from ethers, right? Let's see. Import signer with address from ethers, I guess. Maybe here. Okay. I missed somehow the import. Give me a second. Lock. Okay, this is ethers. Let's do something like this, maybe. No, never mind. Let's make it any. That's fine. But here, give me a second. But here, how to convert this to signer address? Never mind. I can do something like this. This is gonna pass. This is gonna fail right now because we're not expecting this. We expect to be reverted. But this is basically the thing that inside before each hook, I call load fixture once, and then I can use this simple storage contract in all of my tests. Like so here, like simple storage contract. Remove this simple storage contract one more time. Message, and this, if I put it only, it's gonna work right now without using load fixtures, etc. So this is the point, and yeah, good point. Okay, thanks for the cool, thank you. Okay, so difference between scripts and tests. So here I'm gonna present you something that we created. We don't have a lot of time, by the way, sorry about that. But I'm gonna stop sharing this and I'm gonna start presenting share screen window. So you should be able to see my StreamYard right now. Something called Hardhat Chainlink plugin. So if I go to official documentation, this is a general overview for setting up the Hardhat. So we covered all this stuff. Down here, I have a section called working with Oracle. So this is the example of working with blockchain oracles. What is an oracle? Why do we need it? What is Chainlink, etc. The oracle problem, the part of the security architecture, etc. So this is like a piece for getting price data. So how to write Chainlink data feed smart contract, and then here we have a section on randomness. So like how randomness on chain is extremely vulnerable to enemy attack, how it's not secure, how you should use VRF, etc. And here we have something called the mention of something called Chainlink Hardhat Chainlink plugin. So this is literally a plugin for Hardhat, which have some predefined tasks for you. So all of these tasks are going to come from this plugin, while, for example, the deployment script, I will need to write it manually by myself. And here you have an example of how to deal with VRF subscriptions when you're deploying a VRF, for example, VRF consumer contract. So here I'm creating on Goerli a new subscription, then I'm funding it, then I deploy my contract, and then I'm adding it as a consumer. All of this from this deployment script instead of go to a VRF web page, connecting my wallet, add the details manually, etc., etc. Okay, so how to see this contract, see this plugin in action? As said, this is how I'm going to install it. I will need to import it inside the Hardhat config, and I should be able to find the documentation over here. So this is the page for plugin. And if I go here to repository or click beta type over here, there is a thing called documentation. So if I go to documentation.md, I can see all of the available documentation for this plugin, from installation to importing to setting up, and then for all of the different types that this plugin has. So it does have denominations library, it has Chainlink functions tasks, it has, then we have Chainlink data feeds stuff, all the way to the end to the, give me a second, I should rewrite this at Gitbook, etc. But all the way to running a local Chainlink node on a Hardhat network. And this is what we're gonna do. We're gonna run Chainlink node inside your Hardhat network. So if documentation is too much for you, too boring, inside this README file, or here as well, where's the README, we have some example usage. So example number 1, get the latest price of ETH, create and manage VRF subscriptions, from what we saw at the official Hardhat documentation. And finally, this is what we're going to do. We're going to run the local Chainlink node on your Hardhat network. And now that we have our local Chainlink node on Hardhat network, we can write more and more and better tests. And for example, let's say that you want to test the creation of external adapter, for example, it's extremely handy to do this with Hardhat network. Back. I should stop sharing this, sorry about that, and present once again my Visual Studio Code. Okay, so let's expand this terminal as much as possible. I'm gonna clear it. Yeah, as we saw, so I should npm install save dev Chainlink Hardhat Chainlink. This is a plugin for Hardhat. Okay, I install it. Now I should go back to the Hardhat config. Here it is, and add this line: import Chainlink Hardhat Chainlink. Okay, go back, terminal, clear this stuff. And if I do something like this, so npx Hardhat help, I can see all of the available tasks. So these tasks came predefined with Hardhat, and all of these tasks are now new and they are part of Chainlink plugin. So I'm looking for this run a node task. Okay, so I'm gonna split this thing up again, clear. So here I'm gonna run a Hardhat node. So npx Hardhat node, and I run a Hardhat, like local Hardhat node. Secondly, I should have Docker installed. So once again, you'll need to have Docker installed. So I'm going to present, again, share screen, window, where is Docker? Once again, yeah, here it is. So Docker desktop, so we can see here that no containers are running at the moment, but Docker is up and running. And if you don't have Docker, go to Docker desktop, just download it, and you're good to go. So Docker is necessary for this thing to work. So I'm going to stop sharing right now and go back to Hardhat. So here, I'm going to type the name of the command, which is, if I recall correctly, npx Hardhat Chainlink run node. So npx Hardhat Chainlink run node. Okay, this is now spinning up my Docker container, etc. And now node is up and running, which I can see now inside my Docker desktop. So share screen, once again, tar screen, you can see here that now my dist image is up and running. So we have Hardhat progress and Hardhat node, so Chainlink node and Postgres database for the node, and that's it. You have spin up your Chainlink node on your local Hardhat network. Is Docker an external software? Do we need to download it? Yes. So you need to go to Docker. I'm going to paste the link. So Docker desktop, Docker. So you're going to download it from here. And then you're going to just need to run it, and that's it. So download it from docker.com. Docker desktop is the official website. Okay, so if I go, give me a second here. Yeah. So then let's present present screen window. I'm gonna present StreamYard once again. So if I go here, it says, okay, a couple of important nodes, blah, blah. But if you visit localhost on port 6688 in your browser, and I can visit like this, you should be able to see operator UI. So this is like a proof that your node is up and running on Hardhat network one more time. So if we go back here, there's like credentials for me to log in. So user@hardhatchainlink.io. This is like a dummy user, but it's like hard coded. And password is strong password 777. Don't worry, everything's on your local machine, so there is no like security issues of any kind. If I hit access account, no, I'm not gonna save it. You can see the actual dashboard of the local Chainlink node. Okay, pretty handy, right? Finally, because we don't have a lot of time, documentation for plugin once again available here. Finally, there is this thing called Chainlink Hardhat Starter Kit. So Hardhat Starter Kit is a boilerplate repo for testing, deploying, and shipping Chainlink Solidity code. It's extremely useful for you if you want to like build really fast hackathon projects. Just spin it up. You have a set of contracts over there with all of the like with the usage of all Chainlink services. Then scripts, deployment scripts, and regular scripts like reading price, then tasks, couple of predefined tasks, and finally set of tests. So you can see how you need to properly write Chainlink tests. There is another branch called TypeScript. So this is a JavaScript version. If you want to use TypeScript, just switch to TypeScript version of the Starter. It has this blue thing over here. I'm going to show you how to check out once again. And it has something called Git pops. So if this is 2022, let's say, so if you have contributed to Hardhat Starter Kit, you should be able to get a Git pop for 2023, etc. So how to contribute? Start with open issues, or see if there is like open issues. There are a couple of ones that are like good first issues, like this one, so you can go jump into it, or straight open a pull request. And you can see here, let's say if there's like some this is like a typo in README, for example, this is a merge pull request, or who open it, blah, blah, blah. Okay, and he became eligible for Git pop, etc., etc. So you can even build on top of it, but let's say how to use it. So we first need to, let's see, we first need to git clone it. We have actually quick start guide over here. So I'll need to git clone it and then cd into that repo. Okay. Let's stop sharing this one and continue with the sharing of my integrated terminal. So share screen, terminal over here. I'm gonna cd out of it, and so git clone Hardhat Starter Kit, cloning into Starter Kit. Okay, and I'm gonna cd Hardhat Starter Kit, and open again my Visual Studio Code. Let's see how. Okay, stop sharing this thing. I'll switch between a lot of things. Sorry about that, guys. So this is a welcome screen. Okay, so yeah, welcome screen. So we are now inside Hardhat Starter Kit. Contract, scripts, tasks, etc. A lot of stuff over there. How to use it? Open new terminal once again. Hit npm install first. After hitting npm install, you can again write npx hardhat test, compile, etc. And if you want to switch to TypeScript version, just type something like this: git checkout TypeScript. Okay, and now we can see that our tests are written in TypeScript. If I git checkout main, go back to the main, you can see that your tests are now in JavaScript. So there is both JavaScript and TypeScript version of this starter kit. Okay, do we have any, yeah, Andrew who gotten GitHub, yeah, you're welcome. Do we have any final questions? So again, Hardhat Starter Kit. If you want to see how to use it, just go to the official repo, and here inside the official repo, I'm going to present that screen once again. So inside the StreamYard, inside this repo, so there is a quick start guide. We did that. Then npm install, we did that for our previous Hardhat project. Don't need to call it. Then I can call tests. Then if I want to go to TypeScript, git checkout TypeScript, npm install once again. How to use it? If I want to deploy smart contracts, just hit npm run this deploy. If I want to run a local network, hit this command. If I want to deploy to like mainnet or Polygon, which is like a production ready network, follow these steps, etc., etc. If I want to run forking tests, over here, auto-funding couple of predefined tasks, tests, performance optimizations, etc., etc. How to interact with already deployed contracts, couple of commands over here. Just follow along and copy paste stuff. Read carefully, and everything's gonna be pretty much the same as written here, and it's gonna be extremely easy. If something doesn't work right, or there is like a typo or something, open an issue or open a pull request. You'll have a Git build, and the Chainlink Labs guys are going to actually help you for your pull request to be actually merged. So you can merge, so you can even level up your coding skills, like by contributing to the open source projects like this. Coming back to the story, this is a link for plugin if you want to use it, and this is a guide for the usage of a plugin. So I think we are on time. We were a bit late. So any final questions? If you have it, feel free to write them now. If not, thank you for attending another Chainlink Hackathon workshop. I hope this was useful for you. I try to keep it on a reasonable pace so everyone can follow along, code along. Once again, what we covered were four things. So creation of Hardhat project, writing unit tests with TypeScript, usage of a Hardhat Chainlink plugin, especially for running a local Chainlink node. And finally, I showed you that Chainlink Hardhat Starter Kit exists, which is a hackathon boilerplate ready project for you to get started with the usage of Chainlink services. Yeah, thank you for joining me. Thank you for your time, and we are gonna see you next. Yeah, I hope that you're gonna build some amazing stuff during this hackathon. Bye bye.